Example 1 says, consider the equation y is equal to 3 raised to the x plus 2. Divide the interval from 1 to 3 into 4 equal subdivisions. So we're going from 1 to 3, and we want 4 equal subdivisions. So it's going to look something like this. So let's see, that's 1, and then 2, and 3. And we are using trapezoids because the trapezoid will give me a little bit better estimation in this case than a rectangle because it's fitting the curve a little bit better. Okay, but here's the key, okay? The trapezoid is not lying on its base, it's standing up. So it looks something like this. So this is going to be a base, and this is also going to be a base. And then the height of the trapezoid is going to be the bottom. The area of a trapezoid, do we remember the area of a trapezoid? Did we bring our geometric A game this morning? Apparently not. It's the height divided by 2 times base 1 plus base 2. Okay, so let me label these a little bit. I'm going to call this base 1, and this base 2, and this base 3, and this base 4, and this would be base 5. And so my height here is going to be given by this value. So when we are working these, my height is going to be the x values, and the bases are going to be the y values. So I'm going to go through for the purposes of the notes and set these up here. When you are working these, you do not necessarily have to go through these steps, okay? But let me work through this. Let's write the formula for the first trapezoid there. It's going to be the height divided by 2, and then we would have base 1 plus base 2. And then my second trapezoid here, it's going to be the height divided by 2, and then base 2 plus base 3. And my third trapezoid is going to be the height divided by 2 times base 3 plus base 4. And then my last trapezoid is going to be height divided by 2 times base 4 plus base 5. And so I did that so that I can show you where this next formula comes from, because if all of my subintervals are equal, then I can factor out the height divided by 2 because they're all the same. So this is going to give me height divided by 2. And then also notice, if I have equal subintervals, my first base and my last base are used once, and then the middle bases are used twice, because base 2 is the part of the first trapezoid, and it's also part of the second trapezoid. So I could write it like this. I would have base 1 plus 2 times base 2 plus 2 times base 3 plus 2 times base 4 plus the last base. Okay, but this only works if my subintervals are equal, which they are in this case because it says 4 equal subintervals. All right, so let me go ahead, and again, you don't have to do this next step if you're working out the problem. on your homework, but I want to show you the step-by-step process on the notes here. So what is my height of each of the trapezoids in this instance?
X value.
It is the x value, which is what in this case? How do you know? The interval goes from 1 to 3, and there are 4 equal subintervals, right? And so that makes my height 1/2. And then my base 1 is going to be a y value. So in this case, looking at base 1, it's going to be y of 1 plus 2 times base 2, and base 2 is going to be y of 1.5 plus 2 times y of 2 plus 2 times y of 2.5 plus my last base, which is going to be y of 3. Okay, and so, like I said, if you're working these out, I don't need this line. I need the next one, but I want to show you where these values come from. So let me work this out. 1/2 divided by 2 is going to be 1/4, and then I need y of 1. So I'm going to take 1 and plug it into my equation here, and that's going to give me 3 raised to the first power plus 2, which is 5. Plus 2 times y of 1.5, and here I probably need to use my calculator. Okay, so get your calculator and let me switch over to my TI-84 here and put the equation into y equals. So I have 3 raised to the x plus 2. And I'm going to go to the table. So I'm going to hit second window. I'm going to start my table at 1. And then I want to change the table by 0.5. So that when I go to the table, second graph, okay, here I have the values that I need. Okay, so y of 1 is 5, y of 1.5 is 7.1962, y of 2 is 11, y of 2.5 is 17.588, and y of 3 is 29. Okay, everybody see that? So let me go back to the notes here and put in those values. So I have 2 times 7.1962 plus 2 times 11 plus 2 times 2.5 was 17.588 plus 29. Okay, so let's add all of these values inside the parentheses together. And then don't forget to divide by 4 because I have the height divided by 2 outside there. And let's calculate the estimation. So go ahead and do that for me with your calculator right now, please. And check your answer with your neighbor. And then with me, let's see, I got 26.392 square units there. So any questions on the first example there about anything that I did before we move on? All right, well, let's do a little unequal divisions. It says estimate the area between the same curve and the x-axis on the interval from 1 to 3 using the trapezoidal rule with divisions at the following values of x. Okay, so we're going to start at 1 again. We're going to end at 3, but this time we're going to go 1.3, 1.9, and then 2.4. So a rough estimate looks like that. I've got 1.3, 1.9, and then 2.4 there. So this time my heights are unequal. And so I'm going to have to calculate each trapezoid separately. So the first height, it goes from 1 to 1.3. So my height is going to be 0.3. And don't forget to divide by 2. And then my bases, I need base 1 and base 2. So base 1 is going to be 5. Right, if I plug 1 in. But now I need to plug in 1.3. So I think I need to go back to my calculator now. So let me do that. I'm going to go back to my calculator here, and I'm going to change my table. It's the same equation, but I'm going to change the table. We're going to start at 1, and let's change by 0.1. And look at the table. And there I can get 1.3 at 6.1712. So let me get back to the notes there. So my first trapezoid here is going to be 0.3 divided by 2 times 5 plus 6.172. And that's my first trapezoid. The second trapezoid, it goes from 1.3 to 1.9. So my height is 0.6. And I divide by 2. And my first base is going to be this value that I just used, which is 6.172. And the second one is going to be y of 1.9. So look on your calculator on the table and figure out y of 1.9. And let's see, I got like 10.0636. Something like that. And that's my second trapezoid. So the third one, I'm going from 1.9 to 2.4. So my height is 0.5. I'm going to repeat this base. So 10.0636. And then I need y of 2.4. So look on your calculator. And I got 15.967. And then our last trapezoid, we're going from 2.4 to 3. So my height is 0.6. I divide by 2. I'm going to repeat this one, 15.967. And then I need y of 3, which is 3 cubed plus 2, which is 29. Okay, so I have all of these values. Take your little calculator now and find the estimation of the area. Yes, Shelby. Got it? And let's see, tell me what you got, please. Oh, somebody, anybody. Oh,
There's a lot of numbers in the house.
are you whining, Shelby? There's no whining in calculus.
I just don't know how quickly I can type them in.
Got it?
No, I was just waiting for somebody else to say that.
I see how you are. That'll probably work out well on the test, right?
I can figure it out if I want to.
Oh, okay. You just don't care to.
Well, I'm just being lazy.
Okay.
26.5.
26.544 square units. And that is pretty close to our previous estimation, right? It's the same interval where you were just dividing the trapezoids up a little differently. Okay?
So if this
Yes.
is like pretty much exact, basically, why do we do the LRAM right?
Well, it's not exact, but I'm glad you mentioned that because very, very soon we're going to learn how to do it exactly, but these are estimations, okay? And so the two ways that they are estimating are with the Riemann sums and then the trapezoidal rule, okay? Which, as a general rule, I mean, I guess it depends on the function, right? But the trapezoids will give you a pretty good estimation, but they are not exact. That is a preview of coming attractions.
So we'll learn how to estimate it, we're gonna learn how to actually do it.
Yes, very soon. Okay. All right. Any other questions on the first page? Well, turn the page. I got two more examples. Example 3. At Calculus Inc., production rates are monitored closely in order to deter yo-yo theft by the workers. It's becoming a problem. On Friday, November 4th, production rates were recorded at the times in the table below. Using a trapezoidal sum, estimate the number of yo-yos produced on this date. All right, so sketch a little graph here. My time is going to be on the x-axis, and my production rate is going to be on the y-axis. So the differences in the times are going to give me the height of my trapezoids, and my production rates will be the bases. So let's set this up. The first trapezoid, I'm going from 8 o'clock to 9 o'clock. I'm going to calculate the time in hours. So my height is going to be 1 divided by 2. And then the two bases will be the production rates for this interval. So 450 plus 370. And then my second trapezoid, I'm going from 9 to 10:30. So my height is 1.5. Just be careful on the times that you don't make a silly mistake. And don't forget to divide by 2. And then we're going to put in the bases. So I've got 370 plus 400. So go ahead and finish that out, set it up for me using the time intervals and the production rates. And then once I get it set up, I should probably sit back, relax, and let somebody else calculate it for me so that I can be as relaxed as possible. So somebody plug those values in to their little calculator. Don't forget to divide the heights by 2 and crank out an answer. And I will wait here on pins and needles for your estimation of the amount of yo-yos produced during this day.
I got 3,220. Is that a little off?
I got something different.
I got 2,857.5.
2,857.5 yo-yos. We just had to make half a yo-yo there. Couldn't finish it out. That is the correct answer there. So like I said, these are not all that difficult. It's fairly easy to make a little mistake on the calculations because they can be a little tedious, but we are careful in our calculations and that will not happen to us, especially on our quiz on Monday. Okay. So we are going to look at one more example here. Let's bring this home. Due to a bad storm on a low-lying road, a large circular puddle of water forms. The area of the puddle increases as the storm intensifies. The radius of the puddle in feet is modeled by a twice differentiable function r of time t, where t is measured in minutes. For t between 0 and 15, the graph of r is concave up. The table gives selected values of the rate of change, r prime of t, of the radius of the puddle over time, over the time interval from t between 0 and 15. The radius of the puddle is 7 feet when t is 6. Part A. Find the rate of change of the area of the puddle with respect to time at t is equal to 6. Indicate units of measure. So we have a little related rates problem. What am I trying to find? Tell me, please.
The rate of change of the area.
Shall we? Okay, so that is, I want to find
dA over dt.
dA over dt. And what is the formula I'm going to use to find dA dt? It's the area of a circle. It's amazing the puddle formed an exact circle. Crazy. So area equals pi r squared. So I need to take the derivative. The derivative of A is going to be dA dt. What is the derivative of pi r squared? I would hate to forget to tag it, right? So it's going to be 2 pi r and then dr dt. So let's plug in, now that I've differentiated, let's plug in some values that I know. So dA dt I'm trying to find. I've got 2 and I've got pi. What is r? How do we know? It says so right there. When t is equal to 6, the radius is 7. And what is dr dt? How do we know? It says so right there. cleverly disguised. It's in the table. It's r prime of t. The derivative when t is equal to 6. The derivative is 3.4. So now I've got 2 pi times 7 times 3.4, which should give you, let's see, 47.6 pi. And we're going to put the units on there. The area is measured in, oh, I set you up there and I had such high hopes. The area is measured in square feet. So I got feet squared, and the time is measured in minutes. So I've got 47.6 pi, or if I wanted to multiply that out by pi, what's that, like 159?
149.
What is it?
149.5.
You sure?
Yeah.
It is? 149? 47.6?
47.6 times 5.
Okay, 149 point
5354.
534?
540.
54. All right, so that's part A. Part B says use the trapezoidal rule with the data indicated in the table to approximate the number of feet the puddle changed over the time interval from 0 to 15. So now they want us to use a trapezoidal rule to get an estimation using the data in the table. Okay, so again, my height will be given by the difference in the minutes, and my bases will be r prime. So let's set that up. The first trapezoid goes from 0 to 3. So my height is 3, and I divide that by 2. And then my bases will be 1.2 plus 2.3. And then the next trapezoid, I'm going from 3 to 6. So my height is 3. And my bases are going to be 2.3 plus 3.4. So let's keep going. Let's see, I've got get all of that set up. And then I'm gonna plug those into my calculator. And you should get, I got 57.05 feet for my estimation. And that is the trapezoidal rule.